And welcome to our session of week 7 of Database Management Systems course. So if you can listen to me properly, please raise your hands. Okay, thank you. So far we were in this week we were talking about concurrency control techniques, and we studied different locking mechanisms. Like we said here that there can be basic locking, there can be conservative locking, and we said 3 locking techniques. So before proceeding to the remaining lecture, because most of the slide lecture was covered, only a few slides were left, and I want to know, because the midterm exams are quite ahead starting from tomorrow. So do you have any question from about database management systems course? One question was about the submission deadline of assignment. So I already extended the deadline for assignment 3. So now it's after the spring holidays, 1 week after spring holidays, 4th of April. And I have also uploaded study guide for you and the format of question paper. And I also told you that short questions will be from these chapters. And just Amal, do you have any questions? Okay, any questions? So if you explore the Blackboard, you'll find that there will be 10 MCQs from all chapters. There will be, because so far we have studied 6 chapters, so MCQs will be from all chapters. Then there will be 10 true-false type questions and 4 short questions. The short questions can be theoretical questions as well, or can be questions like, okay, I have already uploaded the study guide and midterm exam format on the Blackboard. You can see the announcement page. You can see the announcement page. Okay, I'm repeating it again. I have already uploaded the study guide and midterm exam format on the announcement. You can find it over there. But for you, I'm repeating it here that the midterm exam will be consisting of 10 multiple choice questions, 10 true-false type questions, and 4 short questions. The short questions will be from chapter 17, 18, 19, and 21. So 1 question from each chapter. And the short questions can be theoretical questions. These questions can be problem-solving questions, or these questions can be differentiate type questions, like telling the difference or something. So you have to be prepared for these type of questions. And I have posted the study guide for you as well. So it is containing, although it is containing most of the important topics of this course, but the study guide doesn't mean that the topics which are not there are not included. All the topics, all the course covered so far, including the book chapter, including the exercises, including the end of chapter questions, including the assignment questions. So all of them are included in this paper, and as well as the reading material available in every week is also included. So you should be prepared for that. And as you know that the exam will be of 1 hour duration and 25% weightage. So prepare yourself accordingly. Now tell me if you are finding any difficulty with any topic, or you have any problem with anything, or have you seen the study guide? No, so the study guide is important. The study guide contains the important topics. So these are the topics which you must not miss. Okay? Which you must not miss. You have to read the study guide. I won't say that it's enough. I've already said that all the topics are included in your exam. The study guide contains the important topics. So it doesn't mean that the topics which are not in study guide are not included. You can have questions from those and there as well. Okay? Look at the question at the end of chapter. Given at the end of chapter and try to solve some of the exercise questions. It will be good for you. And I have also, if you have seen the announcement, I have also posted the solution for assignment 1, the question 17.2. As you can see, it will be very helpful for you to see that. Yes, calculation about as you have seen that assignment 1 solution. So the calculation of BFR, calculation of the number of cylinders. So these are important. To try to understand, because the calculations about indexing tables and calculation about this number of tracks, number of cylinders, these are important, and these are topics we covered at the very beginning of the semester in chapter 17. Yes, the calculations are important. Your question was, the calculation is important. Yes, calculation is important. Calculation of BFR, calculation of number of cylinders, calculation of writing the queries, optimization of queries, making the query trees. So these are important. I would say that before reading or going through all the slides of this course, first open the study guide and understand all the topics given in the study guide. Okay, I can share study guide with you. I can go through the study guide for you. Just wait for a second. Okay, so this is the study guide for midterm exam. The first chapter was disk storage, basic file structure and hashing. So you should be aware about it that secondary storage devices are preferred for storage because they have huge storage capacity and they have low cost. And the data is stored as magnetized areas as magnetic surface. The disk stack contains several magnetic disks and connected by a rotating spindle. You should keep the diagram in mind. And disks are divided into concentric circular tracks on each disk surface. Track capacities vary typically from 4 to 50 kilobytes or more. And the track is divided into smaller blocks or sectors. And the division of track into sectors is hard-coded on disk surface and cannot be changed. A track is divided into blocks, and the block size B is fixed for each system. Typical block sizes are from 512 bytes to 40996 bytes. And this is how the disk looks like. You have tracks, you have sectors, and you have here you can see that you have 3 sectors in the figure B. You can see that there are 3 sectors. Then your read-write tab moves to the track that contains the block to which it's performed, and the records can be fixed or variable length. The blocking sector refers to the number of records per block. Blocking refers to the storing of a number of records in one block of the disk. So it means how many records you can save in per block is called the blocking sector. There may be empty spaces in a block if an integral number of records do not fit in one block. And the span records are the ones which do not fix in one block and they require more blocks. So those records which require more blocks are called span records. There may be records which are not filling up the complete block. Now, the file is a sequence of records where each record is a collection of data values. So we should be aware about file descriptor. Blocking factor BFR for a file is the average number of file records stored in a disk block. So how many file records can be stored in a single disk block is called blocking factor. So the calculation of blocking factor, you should be aware about it. The file can have fixed length records or variable length records. So in the exam, like you can be asked questions like what is the difference between unspanned and spanned file records. You should be able to answer such questions. Or what is the difference in contiguous or indexed structure of records. And then operations on file, you should be aware about it, that what is the purpose of if you are performing open on file, so what does it mean? If you are performing read on file, what does it mean? Find difference between find and find next, difference between reorganized and what is read ordered. So you should be aware about this. And unordered files, how they are stored, and what is the purpose of linear search? Is it efficient or not? So if you are keeping ordered files, so either linear search is better on ordered file or boundary search is better on ordered files. Then the average access time. The average access time to access a specific record from a given type of file. So if the type of organization is heap, unordered, it is a linear search, so the average blocks to access is D by 2. And if it is ordered, then again D by 2, maybe the required record is in the middle. And if it is ordered, but you are using boundary search method in ordered, so it will reduce your time, because in the case of boundary search, it should be organized in the form of a tree. So in the top, if it is organized in the form of a tree, so the average block to access a specific record will be log 2b. Okay, so you should be aware about these application styles. Then the hashing for disk files is called external hashing. So what is hashing function, and so you should be aware about it, that what is hash key. Then dynamic and extensible hashing techniques. So what is linear hashing, what is extensible hashing, and you should be able to answer such questions. And then using, like if we talk about RAD technology, so what is the advantage of RAD, what RAD stands for, and why we have adopted this technology. So like it is a national solution in a large area of small independent disks. It has a single high performance logical disk. So there are many disks, but they are acting up as a high performance, single high performance logical disk. And we use the concept of data stripping, which utilizes parallelism to improve this performance. So what does data stripping mean and how it improves performance? So as you can see here in this figure, that stripping of data in this is a bit level stripping, and this is block level stripping. So if you do, how does it help you out? You can see that you have disk 0, 1, 2, 3. So you can see here that how you have placed the data on these disks. Either we keep the blocks, slice stripping or bit-wise stripping. Then these are the different levels of these. Like if you are using RAD level 0, so what is the problem? What are the advantages? So RAD level 0 has no redundant data and hence has the best write performance at the risk of data loss. Although the write performance is best, but you have a risk of data loss associated. Level 1 use mirror disk. Level 2 use memory style redundancy by using Hamming codes. So you should be aware about Hamming codes as well. Level 6 applies the so-called P plus Q redundancy scheme using Reed-Solomon codes. So I'm not saying that you should be aware of the details of Reed-Solomon codes, but you should know that level 6 use Reed-Solomon codes. And level 2 use having distance, and level 0 has no redundant data, so you should be aware about this. Then when these organizations are used, then what is the purpose of storage area networks, why they are used, and why we are moving to the concept of storage area networks. And chapter 8 was about indexing structures for files. So also indexes. What are indexes? So single level index is an auxiliary file that makes it more efficient to search for a record within a file. It is specified on one field of the file, but it can be specified on several fields as well. So one form of the index is the file of entries field value pointed to the record which is ordered by each file. The index is called an access path on the field. So index file really occupies considerably less disk blocks in the data file because entries are much smaller. And if you are using binary search and the index, so it can really use directly to point it to the file record. The index can be dense index or sparse index. So you should be aware about the difference or description of these. Then this is an example that if you have a record size given, like this question is just like the question I have given you in the assignment. So like if you have given block size, you have number of records given, you have record size given, so you calculate blocking factor using this formula, the number of file blocks you calculate, then you specify that if a particular field is composed of a particular number of bytes, then what is the size of the index entry, so what is the index blocking factor. So we should be aware about these calculations, which are done in your assignment. Then there are types of single level indexes, primary indexes, how primary indexes are stored, and then what clustering index is, which information clustering index needs, and then this is the properties of index size. You should be aware about this because this is summary table, so you should remember this. Then what are multi-level indexes and why we are going for multi-level indexes, and what we are using B trees and what we are using B plus trees. So you should know about the difference between B tree and B plus tree, and then why these data structures are used. And in B trees, like this is the difference. In B trees, pointers to data record exist at all levels of the tree, and in B plus tree, all pointers to data exist at the least level nodes only. And that's why the B plus tree is the balanced tree. And you can see there is a B tree structure. And then chapter 19 was about algorithms for query processing and optimization. So what is query optimization? The process of choosing a suitable execution strategy for processing a query. And two types of representations can be run for query tree and query graph. So the query block is the basic unit that can be translated into algebraic operators and optimized, like any select from where expression is the query block. There can be nested queries as well, then there can be aggregate operators used as well. Now, although this figure is not much visible, so I would like to I think it is not visible in the study guide which I have given to you as well, but you can see it from your slides of that chapter. So how you should translate first query into relational algebra. So you should be aware about, although I'll not be giving you very complex queries, but you may be given a query or you may be asked to translate into relational algebra, and you may be asked to make a query tree with or initial tree or optimized tree, or optimization up to any level. I'll not be asking you to make a final tree, but you may be asked to make a query tree for a given SQL statement. Like for example, here's a query, like you know the example, then relational algebraic expression, it's query, it's another query, and this is the initial trees, which are possible trees which can be made for this. Then general transformation rules for relational algebra. So there are certain cascade of these are the properties: commutativity of selection operators, cascade of join, commuting, select with join. So you should be aware about these properties. Then what kinds of query execution plans can be: materialized evaluation and pipeline evaluation. So in materialized, the result of an operation is stored as a temporary relation, and in pipeline evaluation, as soon as the result of an operator is produced, it is forwarded to the next operator in the system. So these are two types of evaluations. Then when you are performing cost-based query optimization, the issues are which cost function to use and the number of execution strategies to be considered. Then these are the cost components for query execution. Like when you want to calculate cost for a particular query, which components are important? So the first is the access cost to secondary storage. So how much time, what is the cost of accessing the secondary storage? What is the storage cost? What is the computation cost? What is the memory usage cost? And the communication cost. So you should be aware about all of these. And the different database systems may focus on different cost components. Then catalog information used in cost function, like about the size of field, we keep certain information, and then indexing and display attributes. So these are the factors which are stored for them, and then the cost functions which you can use for select when you're using select. So these are the cost functions which can be used. Then in Oracle DBMS version 8, there is rule-based query optimization or cost-based query optimization. Two possibilities are there. Then chapter 20 was about physical database design and tuning. So like the factors which influence database design is to like you have to analyze the database queries and transactions. You first collect the following information about query, the files, the attributes on which, like these are attributes which you collect. Then you, for each update transaction, you collect certain information. Then you analyze the expected frequency of invocation of query and transaction. Then you analyze the time constraints of the query and transaction. Then the expected frequencies of update operations, uniqueness constraints or attributes. Then you do certain design decisions about indexing, whether to index an attribute or not, what attributes to index on, whether to set up a clustered index, whether to use a hash index over a tree, and whether to use a running session or file or not. So these are some of the questions, design decisions about indexing. And then the goal of normalization and denormalization. So you performed normalization previously for your relations, but why we are denormalizing now? So this is the question which you should know the answer. And then like what is the drawback of denormalization? As it said that there is a trade-off between update and query performance. And then what is tuning of database? In the process of continuing to revise, adjust the physical database design by monitoring resource utilization, as well as internal DBMS processing to reveal bottlenecks, so the contents and processing data of device. So what is the goal? To make application run faster, to lower the response time of queries, to improve the overall throughput of transactions. So these are the goals for tuning. So you should think about this, and which problems you consider in tuning. how to avoid excessive log contention, how to minimize overhead of logging and unnecessary dumping of data, how to optimize buffer size, and how to allocate resources. So these are the problems. And when you should tune queries. So which query is candidate to be tuned? If it is issuing too many disk accesses, and if the query plan shows that the relevant disks are not being used. That means in such situation, you should tune your query. And there are some typical instances for tuning queries, like use of correlated queries, temporaries are used, if multiple options for joint conditions are possible, the order of table in the from clause may affect the joint processing. So these are some of the scenarios which are mentioned over here, which makes the query a candidate for tuning. Then chapter 20 involves about reduction to transaction processing concepts and theory. So like what are single user systems, what are multi-user systems, what is concurrency, interleaved processing, parallel processing, you should know the difference. Then what is transaction, what is the what is difference in read, retrieval, write, insert, and transaction boundaries, begin and end transactions. And then database is a collection of named data items. So what is granularity of data, what are these basic operation means like read and write. And then the problems where concurrency control is needed. So I showed you in class the examples of these lost update problem, temporary update or dirty read problem, and the incorrect summary problem. So you should. I have not also included the figures in this study guide, but you should know about these problems very well. And then why the recovery is required when the computer system crash or transaction system errors occurs, or there are logical errors. So when recovery is needed. And then transaction, as you know, is atomic unit of work. So what are the possible states a transaction can take up? And there are differences, like what is the difference in partially committed state and committed state? So you should learn about it. And then which operations, like the questions can be like which operations recovery manager keeps track of, and what is commit transaction, and what does it mean, and what is rollback. What is the purpose of rollback? Why we are using this option? Why recovery manager has this option, and why commit transaction is necessary. So undo and redo, how they're like undo is how it is different than rollback. Then why the system log is maintained. Then what is commit point, and what is the rollback point, or why rollback is needed, and what is commit point. And then the asset properties, atomicity. The transaction is atomic. It should be consistently preserving. It should be correct in isolation, and it should have the property of durability or permanency. So when the changes are committed, these changes must never be lost because of subsequent failures. These are 4 properties of a transaction, desirable properties. Then you keep track of transaction schedule or history. I was giving a review session. Sorry, when I open the slideshow, I cannot see your messages which you post on the class panel. So you wanted to use mic. Let me give you microphone. Yes, you can hear me.
Okay,
but not very loud.
I'll try to make it loud. First of all, I want to ask about chapter 19. I want to ask about the binary and linear search. I noticed there is sometimes we put -1 or +1, and it's different concept from chapter 17. Like in chapter 17, in linear, we divide the blocks number by 2. And in binary, we calculate the log base 2 for the blocks number, isn't it?
It depends on
chapter
the
19.
like when you are
Yeah.
assessing from this, which algorithm you are using. Chapter 19. So is it in slide?
Yeah, in the calculation
slide
slide.
number?
I don't remember the number, but it's in the calculation. There is a slide contains all the calculations, I think. No, after that, after this slide, after it.
Okay, let me.
No.
So chapter after this.
19. I cannot.
Which chapter is this?
Okay,
Chapter
that's
20.
19.
This is chapter 19.
Yeah. Okay, after this slide.
After or before?
No, after it.
You are talking about chapter 19?
Yeah, 19.
Tell me where to stop.
Okay, here. No, before. No, not this, before. This is there, yeah. That's one. Yeah. Now here in the linear search, okay, we know that the linear search, we divide the block numbers by 2, so we can calculate the number of blocks or the average blocks that need to access during the search algorithm, isn't it?
In linear search,
Linear, yeah, we divide the block numbers by 2.
equality condition on P. If the record is found, then it is B by 2, otherwise it's B.
Yeah, so just
Because
this
if it's not found, then we will have to search the whole block.
Yeah, so no need to calculate the time required, just the block numbers, the average block numbers.
No. No, we are calculating the cost. The cost for as I said that the cost components include the cost to access the secondary storage. The cost include the storage of how much storage it is taking up, how much time, the communication cost as well. But here I'm saying that if you are searching a record from the disk linearly, and you are using linear search algorithm, then if the record is found, then on average it will take B by 2, number of blocks divided by. So you will explore half of the record.
Okay.
And if it is not found, then you will explore the whole record. So the cost will be higher for that.
Okay, for binary search, in chapter 17, just the calculation, we take the logarithm, the log base 2 for the number of blocks. Why we here add the S, I don't know what is here, divide by buffer factor minus 1. When we use this function?
It's because these are the formulas given by someone who has proposed this cost function. These cost functions are like, we have not designed these cost functions, we are just studying these, that somebody has proposed these cost functions and these are given in our book, and here we are studying these cost functions. So we can use these cost functions to calculate cost. And because binary search, in case of binary search, we create a tree and we suppose that the items placed are in sequential order. If they are placed in some order, like the order can be based on some index key or something. So that's why we say that the cost, if it is found, then the cost will be log 2 of B.
Yeah, I don't understand when I should use the first one or second one.
Like this, you are not required to calculate these costs. See, like these cost functions are just for, like if the result is found, then the cost will be this, and if it is not found, then the cost will be the one which is given above.
So it depends on the.
Okay, you are not required. So this is just for, like you don't calculate these costs because you don't know in advance that whether the block will be found over there or not. But this is the case when it is not found, and this is the one when it is found.
Okay,
so it means this is the worst case and best case.
The first case when we found the result, and the second case when we don't found.
When we don't find. Like as we do in the search as well.
Okay.
Like if B by 2 the record is found, otherwise it's B.
So we should not memorize these calculations deeply. Just as it is in that.
No, you don't need.
Okay, here
you should just understand it.
Okay. Here before the minus, there is a bracket. This is the square bracket before the minus.
No. This is not bracket. This is like as you are familiar with the floor operator. In mathematics, we sometimes use floor operator and ceiling operator. There are two operators. So in floor operators, if the value is 3.16, you consider it 3. And in case of ceiling operator, if the value is 3.57, you consider it 4. You round it off.
Okay.
So whatever value we'll be getting from this, from S over BFR, we'll round it off. So this is a ceiling operator.
Okay, great. Okay, and also for the number S3. Okay, and S3 also here. I think this is fixed symbols like C, S3A, and C are just it's assumption.
Have you seen the book? Is there any description about it? Like what is S? So they are not given any description about S in book. Have you seen that?
Yeah, I read the book actually. I read the book. That's why I'm asking you. I did not understand very well. It's very complicated actually. That's why.
Okay, let me see from the book.
There is a lot of functions. I tried to understand it.
This is chapter.
They gave me a lot of rules, except of rules. I'm feeling lost actually.
Okay, let me see. The description of S must be there in the book. They don't use any term in
but
the
regarding
the
S3A.
It's chapter 19.
Hello.
Which chapter is it? It's chapter 19? Yes, it's chapter 19. Okay, I'm exploring it from book that the description of X is given over there or not.
Yeah, that's 19, yes. 19. Yeah.
It's on page number 713.
Actually, I found a lot of calculations. A lot.
See, they have mentioned it over here there that S equal to 1 in this case. They consider the C as
my
equal to 1.
question is.
Yes.
What?
Yes, Hala, I can't hear you. Please, can you repeat?
Equal to 1? Yeah. For the symbols, is it fixed? Is it a standard symbol?
Yes, these are standard. These are.
For the symbols,
yes.
S3A and S3B.
Yes,
is it a standard symbol or just a function? Standard. Okay. What we mean by increase the X? Yeah. Okay. So here for linear search and linear hashing and static linear hashing, why we sometimes because it's equal 1 or we increase it by 1?
See, if you read page number 713 from your book,
like when
you will find many
primary
formulas over there. Page number 713 of your book, you will find many formulas given over there. These are standard formulas. We don't modify it. Because this as written, the cost for method SI is referred to as CSI. So the method name is SI. Is referred to as CSI block expression.
Mm-hmm. Yeah. But here, why we increase it by 1 when we use primary index? What's the X here? Represents
like it's X.
Yeah, but X represents what?
The primary index to retrieve a single index from a primary index. You retrieve use 1 disk block at each index level, plus 1 disk block from the data file. And the cost is 1 more disk block than the number of index levels.
Okay,
so X is indicating the number of index levels you have explored so far.
Okay.
They have not given the
So I
section of
increased it by one
texts
block.
in-
I
in the
increased
book.
the trees by one
Have you
block.
seen it? Like, it should be there. It just can't happen that they're using
Yeah,
X
I
and
see
it's
it.
not described.
But I read a lot. I try to read it. I read a lot, but I really don't.
They are already defined.
That's my
Like
idea.
if you go to page number
They explain it
712. 712. It's written.
Okay, I'll try.
Like X is number of levels.
Okay, I'll try to review it again. Okay, and also in chapter 20.
Like all the abbreviations are given on all the abbreviations
Okay,
are
I'll try
given on page number
to
712.
go over it again. Okay, for chapter 20.
Yes, because in the slide
1, 2.
Yes.
7, 1, 2 and 7, 1, 3. Okay, doctor, for chapter 22, there is a lot of lux mode. You minimize it just to main mode. We have just to study the mode that you mentioned in the study guide.
For chapter 22, we just read the topics.
Isn't it?
Read the topics which are mentioned in the study guide.
Okay. Because for the
yes, there are a few things which I have not covered so far.
Because there is a lot
read
of
the topics which are mentioned.
Yeah, there is a lot of modes. Like okay, I understand the chapter 22, except the one. Would you please open the last slide?
Which one?
Certify last. The last one, the last slide, the last two slides. The certify last. No, actually, maybe. Yeah, this one. Yeah, what's certify last here? What's the difference between certify last and read and write last?
Okay, so since we have not covered this, so let me cover it first for you. So when you use timestamp based concurrency control algorithm, the timestamp is the one which is a variable or monotonically increasing integer. So we use some timestamp algorithms. So can I turn off your microphone as well so that I can also concentrate?
Yeah. Multi-version approach is clear.
Okay, so this approach maintains a level variant of the data items. Okay, multivariant two-phase locking using certified locks. The concept behind certified locks is to allow a transaction T prime to read the data item X while it is write locked by a conflicting transaction T. So it means if a data item X is already write locked by some transaction, but you are allowing another transaction to read the data item. So this is accomplished by maintaining two variants of each item X, where one variant must always be written by some committed transaction. This means the write operation always creates a new variant of X. So when I said to you before that when you lock a data item, it is locked item for writing, it is not available for others for reading. But now when you use certified locks, it means you are keeping two variants of a data items which is write locked, and you are allowing other transactions to read the data item X. So multi-variant two-phase locking using certified locks, the steps are: X is a committed variant of a data item. Transaction T creates a second variant X prime after obtaining the write lock on X. Other transactions continue to read X. So the X prime is the variant which transaction T has obtained of it. Now T is ready to commit, so it obtains a certified lock on X prime. So the X prime was the variant of X which was obtained by T. Now T is ready to commit, so it obtains a write certified lock on X prime. The committed variant X x becomes x prime. Now C releases its certified lock for x prime, which is x now. It means a transaction wanted to write a data item x. So what it did was, it allowed other transactions to read the data item x and use it, and got another version of x, which means it was calling x prime. Then when it has modified that x prime and has a new value for x prime, what it does is that it, before committing, it gets a certify lock. So the certify lock means the transaction has a certify lock that it can modify that item, that variable. So then a committed version x becomes x prime. So now they have only one variable, which is x prime, and which is also called x now. So there is no x prime after the transaction E has committed. So in this way, the previous one was that one transaction is reading the reading of variable between two transactions was possible. Now in this case, the modified table is this one. If one transaction is reading, other can read. If one transaction is reading, other can write no. This is about the same data item. If one is reading, the other can get a certify lock no. And this is more secure. If one has got a certify lock, the other can read no. So it means now we are allowing that the single variable of the shared variable, it can only be given access to two transactions for reading. Even if it is, if one of them has obtained a lock for writing it, the other will get it, can modify it, but it will get the new version of that, not the same one. So the variable will not be the one. It will get a copy of it, will write it, modify it, and then can replace the value of original one. But once it has obtained that. Then validation of domestic concurrency control schemes. In this technique, only at the time of commit, serializability is checked, and transactions are recorded in case of non-serializability. So it means serializable schedule. So it means once the transaction is over, then what it is about to commit, at that time serializability is checked, and there are three phases: read phase, validation phase, and write phase. And granularity of data items and multiple granularity logging. A lockable unit of data defines its granularity. Granularity can be coarse, it can be for entire database, or it can be fine, a tuple or an attribute of a relation. So the two types of granularity can be there. Data item granularity significantly affects concurrency control performance because it is for single data item. The degree of concurrency is low for coarse granularity and high for fine granularity, because for fine granularity you are only locking some attributes of a relation or a single tuple. Okay, now for my last course, for study guide, I would say that you should start reading from study guide first, read all the topics mentioned in study guide, and then read chapter in detail. For every, you will find many calculations in your book as well, but read the book very, very carefully, read all the topics from there, and that context you can. No, certify locks means that if you want to get a data item for writing, and the others are accessing the data item at the same time, you get another version of it, you modify it, and before you use it for your purpose, you modify it in your calculation. But when you are about to commit, you have a modified value of that variable, you get a certify lock. The certify lock tells that you have got the authority to modify that. So you certify that you have the permission or privilege to modify that value. So when you get the certify lock, and only few I can get a certify lock. So when you get a certify lock, then you can modify the value for everyone, and then your modified value will replace the values for all the others. For other locks, if somebody gets the right lock for that, then the other ones cannot modify it or cannot use it. So they can, when you are writing, the others cannot read it. But this is the one certified lock, the one you get, the another version of it, use it for your own while the original data item is available for others for reading. You are using it for your own transaction, and when you are over, you have modified its value. Now you want to commit. So before committing, you get the certified lock, you write it, replace the original variable's value, and then you replace the original one with the modified one. Okay, this is the problem of certified lock. Optimized tree is a little more balanced, and most of the data items are, or you can say that most of the conditions are at the bottom level. In the initial tree, you may not have the like you make according to the relational algebraic expression, but when you try to reduce the size of relations, you try to pick up a particular attributes. So when most of the operators, most of the selections are done based on the condition are done at the bottom, then that's the optimized tree. And remember, for same query, you can come up with different optimization trees, because this is an open problem where many people are working on it, that how to perform query optimization. So you can't say that the query which I have got is more optimized than the other until you prove it